Okay, so just before we do example 21, we're going to introduce a little bit more language into our sequences and these recurrence relations kind of context. So a sequence is increasing if you think about lots of things. So if we take a graph, how do we know that a graph is increasing? It has a positive gradient. We take dy by dx, the gradient must be greater than or equal to 0. Well, for a sequence to increase, the next term must be greater than the current term. So we can write that using our recurrence relation kind of notation. So a sequence is increasing if un plus 1, the next term, is greater than un, the current term, for all n a member of the set of natural numbers. In other words, at every position. Okay? It's no good just being increasing in a section, it's got to increase for all terms in the sequence as you go from one to the next. Similarly, a sequence is decreasing if un plus 1 is less than un for all n a member of the set of natural numbers. Okay, exactly the same argument. There are some sequences, one of which we've just looked at actually in the last example, which is sort of changing in a sequence, but it goes up and down, up and down. But the key thing is it goes back in a sort of loop. And those sequences are called periodic. So a sequence is periodic if un plus k, so it doesn't have to just go oscillate, it could be over a number of sort of terms, but if un plus k is equal to un for n, for all n a member of set of the natural numbers, and an integer k, a specific value of k. Okay? So we're going to look at some questions that just involve that understanding, but these things are facts, again, which need to be learnt. Yeah? Right? There's no choice about that. Either you learn it or you don't, and if you do, you've got a good chance of being able to answer the questions involving that knowledge. Okay, so example 21. Let's read it, pick out the key information in the usual way. State whether the sequence is increasing, decreasing, or periodic. And part 2, if the sequence is periodic, write down its order. So perhaps we should just go back to these notes that we'd written down a moment ago. The sequence of a period is periodic for all n, remember that, and for an integer k, which is known, which is the order of the sequence. Sorry, I missed that out before. Okay, so let's carry on here. So part A, un plus 1 equals un plus 3, u1 equals 7, so u2, we add 3 to it, so it's 10. u3, we add 3 to it, the previous term, so that's 13, u4 equals 16, etc., etc. So this is clear that un plus 1 is greater than un for all n, a member of the set of natural numbers, therefore increasing. Right, so you can see the sort of nature of the answer. It's got to be clear, and you've got to have that statement to justify it as an increasing function. B. So here we've got un plus 1 equals un squared, where u1 equals a half, interestingly. So we've got un plus 1, the next term, equals the current term squared. So u1 equals a half, u2 a half squared, which equals a quarter, u3 a quarter squared, which is equal to a 16th, etc., etc. But I think it's fairly clear that this is decreasing as you go from one term to the next to the next. So un plus 1, the next term, is less than un for all n, a member of the set of natural numbers, therefore decreasing. Part C. un plus 1 is equal to sine of 90n. Okay, now when we look at this question, there's a difference. Right? We've not had stated our first term, but all we do is begin. u1 is equal to sine of 90 times 1. Yeah, we've put our first term in for n. Sine of 90 is equal to 1. You should probably already know what's going to happen with this from your knowledge of the sine graph. u2 then is equal to sine of 90 times 2, which is sine of 180, which equals 0. u3 sine of 90 times 3, sine of 270, which equals minus 1. And we keep on going. u4 sine of 90 times 4, which is sine of 360, which equals 0. Now what do we notice? Nothing yet. We've got the 0 appearing twice. Let's look at u5. Sine of 90 times 5 is sine of 450, which is equal to the sine of 90, which is 1. And now we've got our oscillating or periodic sequence, because we're going from sine of 90, which is 1, which is the same as sine of 450, which is 1. We could produce a few more terms, but because we know the sine wave, we can be fairly confident now of writing down that un plus k is equal to un. Therefore, for all n member of the set of natural numbers, and k equal to not 5, because how many terms repeat? It's a block of 4 terms that repeat. Yeah, so we've got these 4, whoops, not gone far enough. These 4 terms are the repeating terms. So there's 4 repeating terms, so k is equal to 4. Un plus k equals un for all n members of the set n, and k equals 4, therefore periodic.